Hi, this is Mrs. Baston, and in this screencast we're going to learn how to name acids. So an acid is identified by having a hydrogen and a nonmetal or nonmetals bonded to it. So a hydrogen is going to start with H. So anything that starts with H we're going to name as an acid with the exception of water, which is H2O, and water can behave as an acid, which we'll talk about later on, but we're going to name that according to our covalent rules. Everything else that starts with an H is going to be named as an acid. Now when you have acids, there's actually two different types. There are binary acids, which are composed of two elements, just like the name says. So it's going to be hydrogen and one other element. An oxyacid, just like the name implies, is an acid that contains oxygen. So it's going to have hydrogen, and then usually this is going to be hydrogen with a polyatomic that has oxygen in it. Now when you have binary acids versus oxyacids, they're each named in their own way. So as you're going through your compounds, you have to pay attention to which type it is when you go to name it. So the rules for naming acids: if you have a binary acid, it's named with the prefix hydro, the suffix IC, and that's attached to the root name for the element. So for example, if I have HCl, and notice HCl is binary, there's only two elements there, H and one other element, that would be named hydrochlor, so chlor is the root of chlorine, ic acid. So again, for binary acids, you use hydro, the root of the element name, and IC. If you are naming oxyacids, you have to look at what the polyatomic was. So the name is taken from the root name of that polyatomic ion with the suffix IC or OUS, depending on what the polyatomic ion ending is. So if the polyatomic ion ends in 8, then it goes to ic. So an example would be H2SO4. So SO4 as a polyatomic ion is sulfate. So 8 becomes ic. And this one, instead of just becoming sulfic, it actually goes back and adds that UR back in there. And there's a couple like that do that, where they add a little bit back. So H2SO4 would be sulfuric. One way to remember this 8 to ic, if you remember I ate acid, I feel icky. That's one way that you can use to remember that. If the polyatomic ion ends in ITE, then you use OUS. So our other example here is H2SO3 becomes sulfurous. So H2SO3, SO3 was sulfite instead of sulfate like we had up here. Sulfite, ITE, becomes OUS, sulfurous. So let's look at some examples. Okay, so our first one is HF. So this one is a binary acid because there are only two elements there. So if it's binary, I'm going to put a little B over here so we know that that's binary. We use hydro. So hydro, the root of the element, fluor, and then ic on the end. So hydro and ic with the root of the element. So that would be hydrofluoric acid. My second one is an oxyacid. So all I do for this one is look at the polyatomic. So PO4, I don't use hydro, so the only time you use hydro is if it's binary. So this one I don't, I just look at the PO4. So PO4, if I go back to my polyatomic ions, was phosphate. So phosphate becomes ic. So 8 goes to ic. And this is another weird one where instead of just calling it phosphic acid, it actually goes back to phosphoric. So phosphoric acid. Okay, my next one, HNO3. This is also an oxyacid. So I just look at the polyatomic piece of this. So NO3 was nitrate. So 8 becomes ic. So this becomes nitric acid. Next one, HClO3. Again, this is another oxyacid. So I name it based on the ClO2. So that was chlorite, if you go to your polyatomic. So ite becomes OUS. So this becomes chlorous acid. My last one, H2S. I'm back to a binary acid now because I only have two elements. So I go back to my hydro and my ic, like I did up in the first one. So this would be hydrosulfuric acid. Hydrosulfuric. So again, if you have a binary acid, you use hydro, the root, and ic. If you have an oxyacid, like these middle three, you look at the polyatomic. 8 goes to ic, ite goes to OUS. Okay, so my last thing now is looking at writing formulas. When you write the formulas for acids, we go back to our crossing charges. It's a little bit trickier because you have to figure out what the original polyatomic was before you can cross the charge. If there was a polyatomic, if it's not a binary acid. So if we look at our first one, chloric acid, since there's no hydro, we know it's not a binary, but we still know that all of these are going to start with H. So we know H is going to be our first element because they're all acids. So chloric, ic came from ATE. So that means my polyatomic was chlorate, which was ClO3. H is a +1 when it's in front. Chlorate is a -1. So I crisscross charges, and this becomes HClO3. My next one, sulfuric. Ic came from 8, so this was sulfate. I still start with an H. Sulfate, if I go back to my polyatomics, was SO4 -2. Crisscross my charges. This becomes H2SO4. Okay, my next one, hydrochloric. Now when you see that hydro, now we know this is a binary acid. So a binary acid, again, starts with H, but that means there's only one other element. So this is going to tell me what my other element is. Chlor came from chlorine. So hydrogen's a +1, chlorine's a -1. Crisscross charges on this one, and I get HCl. Next one, another hydro, so I know that's just a binary, so that's just hydrogen and one other element. So iodic came from iodide, or iodine, which was a -1. So crisscross charges, and I end up with HI. Then my last one, acetic acid. I'm back to an oxyacid because there's no hydro. So acetic came from acetate. Still start with my H, so that's a plus. Acetate was C2H3O2-. So I crisscross and I get HC2H3O2 as my acid.